Okay, these are your notes for section 1-4. The journal is listed, so if you'd like to copy that down and choose to do that journal, you need to do 1 from sections 1-4 to 1-6. Okay, objective and what's the point? Today what we're going to do is we're going to make and read graphs. We are going to give the graphical interpretation of the domain and range of a function, and we're going to review different types of numbers. The big thing today is the domain and range of a function. We went over that a lot in class today when we were talking about the calculator window, and that will come into play today on your homework. The graphs of functions are extremely important when making predictions and recognizing trends outside of the math classroom. Domain and range are important so that you are aware of possible outcomes and if your results make sense. Basically, every career you could possibly think of entering makes decisions based on data. In education, we rely on your test scores to see if the things we are doing is working, if you guys are learning a certain way. Businesses, obviously, they'll go off of sales, if certain marketing techniques are working and whatnot. Almost every career uses data, and the graphs of them are very important along with the domain and range to see if what the data you're collecting is giving you possible outcomes and if it even makes sense. Okay, this should be review. These are the different types of numbers. A couple of them might be new to you, but what I'm going to do is I'm going to start at the bottom here because this is how you are taught from a very young age, and then kind of jump to the top and meet our way back into the middle. Natural numbers, when you're in preschool and you're just learning how to count, these are the natural numbers. You're counting numbers. 1, 2, 3, 4, and so on. Okay, when you're learning to count objects, these are your natural numbers. Maybe when you get to kindergarten or preschool, we talk about the concept of 0. It's a little confusing because it's the absence of number, and when you put those two together, that gives you your non-negative integers. I was always taught that they were called the whole numbers, and I remembered it because they started with the number with a hole in it. 0, 1, 2, 3, 4, and so on. Okay, when you were in middle school, we talk a lot about integers, and the integers are your whole numbers with the negative integers. Your negative integers are your negative counting numbers. And when you put those together, that's the bell, sorry. When you put those together, you have all of your integers. They go on forever in both directions, and we have -3, -2, -1, 0, 1, 2, and so on. Okay? I'm going to jump up here to real numbers, and then we'll meet our way back down towards the middle. Okay, pretty much anything that you can graph on a number line is a real number. And for you guys, that should be any number you could possibly think of at this point. All the numbers already listed are obviously real numbers because we can graph negative numbers on a number line, you can graph 0 on a number line, and you can graph positive numbers. Other numbers that we can graph on a number line would include fractions such as 1/2, decimals such as 0.75, repeating decimals, 0.3 repeating bar, special numbers that Mrs. Bruno's fond of such as pi. I can graph pi on a number line. I can't really get it in the exact spot that it belongs, but I can get pretty close. Square root of 2, I can put that on a number line. I can put 3 pi over 4 on a number line. I can put 0.1234 on a number line. All these numbers are real numbers because I can graph them. Okay? I can break these down into what we call rational numbers and irrational numbers. Rational numbers are numbers that you can write as a ratio or a fraction. Okay? 0 can be written as a fraction. 0 or 1 or 0 over any number is 0, so it is a rational number. Your negative and positive integers are also, because -3 over 1 can be written as a fraction, 5 over 1, so on. 1/2, duh, it is a fraction. 0.75, it can be written as a fraction because I could write it as 3/4. Any repeating decimal at all. If a decimal repeats, it can be written as a fraction. It's sometimes tricky to find which fraction, but 0.3 repeating bar is the same thing as 1/3. So yes, any repeating decimal is a rational number. Okay, how about this? 3 pi over 4. This looks like a fraction. It is not rational though because pi is part of it, and pi cannot be written as a ratio of two numbers. Pi over 1, you could say, is a fraction, but I can't just get pi by itself, and that's what I need to happen. So the most famous irrational number is pi. The other famous one, square root of 2, does not repeat. You cannot write it as a fraction. Square root of 3. And then we're going to talk about a number called e. Second semester is also very famous. There are some decimals that you cannot write as a fraction. You don't see them very often, but I'll give you an example of one. 0.1, 0.01, 0.001, 0.001, and so on. Okay, this is irrational. Yes, there is a pattern, but the pattern will never repeat itself. I can do this forever, and because of that, it is an irrational number. Okay, we talked about integers already, so the non-integers are those rational numbers that fall in between the integers. Your fractions that can be graphed and so on are your non-integers. Okay, let's move on. A real function, okay? Almost everything that you talk about this year will be a real function. This is a function whose independent, which is our x, and our dependent, which is our y variable, stand only for real numbers. Basically, if we have a real function, this is something that we can graph on the Cartesian plane or an xy grid, we call it, because you can choose the numbers and all these numbers are going to be real, which means they can be graphed. So if you have a real function, it's good news because you can graph it on the Cartesian plane. Okay, the domain of the function, we talked about this. This is what x can be, and we need to be very aware of the domain of the function today because we talked about in class with the calculator example, we will have restrictions. For example, the speed and the distance in the car stopping problem. You can't have negative speed, you can't have negative distance. So when we looked at that entire graph, which I think looked something like this, it's really bad, pretend it was good. This part of the graph meant nothing in the context of the problem. We were only concerned with quadrant 1 because that was the only part of the domain, the x values that made sense was starting at 0 and going on, and actually we stopped at 70. So there were restrictions on our domain there. Okay? So moving on, the range of a function is what y can be. It is the dependent variable. If a function is graphed, you can tell what the domain and range are by looking at the graph. For example, and we are going to have lots of practice with this. Some of it is going to be a little confusing at first. If you had a parabola, I'll go back to the one that kind of looks like the one we had. I wish I could do a better job graphing that. Okay, what can the domain be? Well, I could pick whatever I wanted for x. If we were talking about the context of the problem, we know we are only looking at the positive values. Okay, the range from here appears that I can have y values that come out that would be greater than this line that I drew. Okay, again, in the context of the problem that we were talking about, we were only worried about this quadrant 1, so then that you had further restrictions. How do you know what you're looking at? Well, you have to be really careful. You have to be smarter than the graphing calculator. That graphing calculator pops right out into that window that's standard for your calculator. You have to change it to make sure it makes sense to the problem. Keep in mind that a lot of the word problems have real-world context. So then you need to change that window so that you're looking at the appropriate graph. Okay, this is probably what will be tested on or quiz on the most from this section, the set builder notation. The rest is kind of just review and like skills with using the calculator. The set builder notation is new. Okay, this is what it looks like, and this is how you read it. You read it as the set of all x such that 0 is less than or equal to x and x is less than or equal to 70. Okay, here's how it works. We use set builder notation when we talk about restrictions. We use it all the time with domain and range. This is how I want you to write something if I'm asking you what the domain and range are. If I ask you what the domain and range are, write it in set builder notation. It starts with the forehead, nose, and chin thing. I know that's not the name, it's a brace. I call it forehead, nose, and chin. It helps me draw it. And then the first thing you do is say, okay, here's what I'm talking about. I put an x here. That means I'm talking about domain because domain is what x can be. So we say the set of all x x. This is what I'm talking about. It's like a disclaimer. This long line means such that. You will use that in your math career from here on out. The set of all x such that, then you put your restriction. So what is the rule? Tell me what x can be. And for our example with the car stopping, we said the speed had to be between 0 and 70. Okay? The set of all x such that, and then we already talked about all this. Okay, now what if your car could go infinitely fast? It could just keep going and going. That'd be awesome, some of you say. And I say it'd be really dangerous and stupid, but it's okay. The set of all x such that, we can just say x had to be positive. X is greater than or equal to 0. That might be a restriction. There's lots of ways it can look, but here's how it works. Forehead, nose, and chin. What am I talking about? Such that, what is the rule? You'll have lots of practice with that this year, and you'll get pretty good at it. Then Mrs. Thurston will be like, oh, you're so smart. And you'll be like, Mrs. Bruno taught me all of this. She is a genius. And then Mrs. Thurston will smile and be joyous, even though she scares me. Okay, we did the activity today. This was a really good example, and I want you to kind of review this here, guys. Of domain and range. Really keep track of what your window is, what you're looking for, any restrictions you have. This is what you started with. This meant nothing to me. I was only concerned with this portion of the graph. Okay, I think that's all. Yep, that's all, folks. There's Porky. Enjoy your homework. Study up for that quiz tonight, and we'll do 1-4 after the quiz tomorrow. If you want to get a jump on it tonight, that'd be great.